Question number 27 states all the restrictions on the value of x if we have the following. So we have, first of all, x log. So our first restriction should be x must be greater than 0. We cannot have an argument less than 0. So that's the first one that we're going to state. Okay. We also have to make sure that the denominator is not equal to 0. So we have to say that log x cannot be equal to -3. Okay, that means that x cannot be equal to 10 to the power -3, or in other words, x is not equal to 1 over 1000, or we'll write that as 0.001. Okay, so that would be, I'll just highlight that. That one comes from that one there. Okay, we have another restriction that log x cannot equal 3. So log x cannot be equal to +3. That makes x not equal to 10 to the power 3, or x is not equal to 1000. That comes from the other denominator. So we can't have the denominators equal to 0, and they're reflected in these log values here. Okay, so those are the restrictions, and it asks us to solve for x. Now, solving for x in this case, we have to be able to solve for the log x first. Okay, so we're going to have to algebraically solve for the log x. So first thing is, I'm just going to cross multiply this, and so I end up with, let me go write this out, 2 plus log x. Again, since we've stated the restrictions, we can move that out of the denominator, and that's equal to -2 log x times 3 plus log x. So this is really a quadratic equation in terms of log x. So once we solve for log x as a quadratic, we can then solve for the x value. So expanding this out, I get 6 2 log x, -2 log x plus 3 log x means I have 1 log x. And then log x times log x, I end up with log x squared. On this side, I end up with -6 log x minus 2 log x, and that log expression squared. So this is why we have a quadratic equation, because the log is squared, so it ends up being a quadratic. So I'm going to solve this as a quadratic equation first. So solving this as a quadratic equation, I'm going to add 2 log x squareds on both sides, so I end up with log x squared plus, I'm going to add 6 log x to both sides, so I end up with 7 log x plus 6 equals 0. So as a quadratic equation, solving this becomes log x plus 1 log x plus 6 when I factor it. And so here I can solve this. I get log x equals -1. That means x is equal to 10 to the -1, which is 1 over 10. Here we end up with log x equals -6. Okay, and then we can solve for x. X is equal to 10 to the -6, or 1 over 1 million. So those are my two solutions. I'm going to check my restrictions. Yeah, it's not equal to 1000 or 1 over 1000, and the x values are bigger than 0. They are both positive, so they're both valid solutions.